Hello friends, in this AV we are going to discuss some of the important numericals from exercise 8A of class 10 physics, that is the chapter current electricity. For solving the numericals of the first exercise, that is exercise 8A, we will be using these formulas which are V is equal to IR. This comes from Ohm's law. This can be coined in terms of I, that is current. So from this, I is equal to V by R, or R, that is resistance, is equal to V by I. The second formula that we might need is current is equal to charge flowing per unit time, that is Q by T, and we know that Q is equal to NE, that is N is the number of electrons and E is the charge on one electron divided by the time taken. The third formula that we will require is resistance is equal to rho, that is specific resistance or resistivity, multiplied by L divided by A. So here specific resistance will be R into A divided by L. And finally the conductivity is the reciprocal of resistivity. So with these formulas we will try to do some of the important numericals of exercise 8A. So let's check the first question. It says, in a conductor, 6.25 into 10 raised to the power 16 electrons flow from its end A to B in 2 seconds. Find the current flowing through the conductor, and we have been provided with the value of E, that is the charge on one electron. So let's write the given things, and we have to keep in mind that the electron is flowing from A to B. So current flows in the opposite direction of the flow of electrons. So current will flow from B to A. So here we have written the given things: the number of electrons flowing, the time, and the charge on one electron. The question says find the current flowing through the conductor. So from here we have been given N, we have been given E, and we have been given T, and we have to find current, that is I. So I is equal to Q by T, that is equal to NE upon T. So we find that we have been provided with N, we have been provided with E and T. So we will be using this formula and we will find the value of current. We know I is equal to NE upon T. So the value of N is 6.25 into 10 raised to the power 16 multiplied by the charge on one electron, that is 1.6 into 10 raised to the power minus 19, divided by the time, that is 2 seconds. So when you multiply, you will get 6.25 into 1.6 as 10, and 19 minus 16 will be 3. So we have 10 to the power minus 3 divided by 2. 10 divided by 2 will be 5 into 10 raised to the power minus 3, which can be written as, this will be in ampere, and the current will flow from B to A, because the direction of flow of current is opposite the direction of flow of electrons, or this can be rewritten as 5 milliampere. If you have any doubt in this regard, you may please check the conversion unit given on the very first page of this chapter. Let's try some other question. Question number 2 is of the same type. Just have to find the value of N. So you'll be using the same formula as question number 1 and you'll find the value of N. Let's see number 3. It says find the potential difference required to flow a current of 200 milliampere in a wire of resistance 20 ohms. So first of all, we'll write the given things. So here we have written the given things. Current is equal to 200 milliampere, that is 0.2 ampere. We just divided by 1000, and resistance is given as 20 ohms. So we know that V is equal to IR. This formula comes from Ohm's law. So we just put the values. Current is 0.2 multiplied by the resistance, that is 20 ohms. So if you multiply, you get 4, and the unit of potential difference is volt. So this is how we solve this question. Now question number 4 can be done in the same manner using the same formula, just that we'll have to find the value of R. Now we go straight to question number 8. It says two wires of same material and same length have radii 1 mm and 2 mm respectively. Compare their resistances and their specific resistances. So resistances we will compare, that is R1 and R2, and specific resistances we need to compare the value of rho. Now here, since we have to just compare, so we can just leave the lengths in millimeter. We do not need to change it into meter, that is the SI unit. So I'll just write the given things. So here we have written the given things. We have assumed that let L be the length of both the wires. Radii is given as 1 mm and 2 mm. And we have said that let R1 and R2 be the resistances of the two wires respectively. The first part of the question wants us to compare the resistances. So for comparison, we will just write R1 by R2. That is equal to, this is going to be a ratio. So we are using this formula. R is equal to rho L by A. So for R1, it is going to be rho now rho L by A1 and rho divided by rho L by A2, because area is going to vary because of the different values of the radius, but the specific resistance rho and the length of the wire L are same in both the cases. So we will just rewrite the equation, that is rho L by A1 into A2 by rho L. Now rho L and rho L will cancel out and we are left with A2 by A1. Now area is pi r square. So radius, this is for the second one. For the second wire, the radii is 2 mm. So pi r square divided by pi and r square. The radii for the first wire is 1. Now pi cancel out and we get the answer as 4:1. Now the second part of the question says we have to compare the specific resistances of the two wire, that is the value of rho. So here rho 1 by rho 2 is equal to, we'll write R1 here, R1. Now we will be using this formula, rho is equal to RA upon L. So I'm not writing it, I'm jumping few steps, I'm directly writing the value of A. So that is pi into R square, so 1 square will be 1 only, divided by L. This is for rho 1, and for rho 2 we have the value R2 pi 2 square, that is 4 by L. So if we cross multiply, we will get R1 pi into 1 divided by L multiplied by L R2 . by 4. Now L and L will cancel out, pi and pi will cancel out. Let us rearrange these terms. Let's write R1 by R2 together, because we have already calculated the value of R1 by R2, that is equal to 4:1, multiplied by 1 by 4. So R1 by R2, the value is 4 by 1 or 4:1 into 1 by 4. So this cancels out and we have 1 by 1, or we can write it as 1:1. So the value of these specific resistances, if we compare, it will be 1:1. Now let's check another question. Now number 9 can be done. 9 and 10 are of the same type, so we will try number 10. It says a wire of resistance 3 ohm and length 10 centimeter is stretched to length 30 centimeter. Assuming that it has uniform cross section, what will be its new resistance? Now here we have to understand that once we increase the length of the wire, the area of cross section decreases. So first let me write the given things. Now here I have given the written things. The resistance of the wire is 3 ohm and the length of the wire is 10 centimeter. Now we know that R is equal to rho L by A. We are using this formula, R is equal to rho L by A. Now they have said that the wire is stretched and the new length, let's say that the new length is L prime, is 30 centimeter. I can write this 30 centimeter as 3 times of L. That is, the new length is 3 times the old length. Now length has increased by 3 times, so area will decrease by 3 times. So the new resistance, let's say that R prime, the new resistance is rho L. Now L is 3 times the L. New length is 3 times the old length, divided by area. Area will decrease by 1/3. So if we cross multiply, we will get 3 and 3 will be multiplied. So we have 9 rho L by A. Now if you check, rho L by A is nothing but R. So 9 into R. What is R? R is 3 ohms. So we get it as 9 into 3, that is 27 ohms. So the new resistance will be 27 ohms. Now we check another question. After number 10, question number 11. It can be done in the same way. What is the new resistance? We just have to take care of one thing. The question says a wire of resistance 9 ohm having length 30 centimeter is tripled on itself. So in this case, the new resistance, for the new resistance, length decreases by 1/3. So new length will be L by 3 and the new area will be 3 times the old area, that is 3A. If you put these values, you will get the answer. Now we go directly to question number 13, that is the last question of this exercise. It says the filament of a bulb takes a current 100 milliampere when the potential difference across it is 0.2 volt. When the potential difference across it becomes 1 volt, the current becomes 400 milliampere. Calculate the resistance of the filament in each case and account for the difference. Now we will calculate the resistance in each case. The difference is, once the current increases, then automatically the temperature will also increase, and if the temperature increases, the resistance will also increase. So let's write the given things here. So here for the first part, the given current is 100 milliampere, that is equal to, divided by 1000 to convert it into ampere, that is 0.1 ampere. Potential difference is 0.2 volt. So we know that V is equal to IR. We have to calculate the value of R. So from here, R is nothing but V by I. We have the value of V, that is 0.2, divided by the value of I, that is 0.1. When you divide it, you will find the answer to be 2 ohms. Now, the second part of the question, it says the current goes to 400 milliampere divided by 1000 to convert it into ampere, that is 0.4 ampere. Potential difference is 1 volt. So in this case, the resistance R will be again V by I. Put the value of V, that is 1 volt, divided by the value of current, that is 0.4. So this is nothing but, after division, it comes to 0.25 ohms. And to compare, in the first case, when the current was 100 milliampere, the resistance was 2 ohms, and when the current increased, then it becomes 2.5. Simple logic is, when the temperature increases, the resistance will increase. That's all in this AV. Study well. God bless.